Hello, welcome again, everybody. I was asked by a couple of viewers in comments about PCM boards, which are the computer boards, and there were problems, no communications. If you have no communications, and usually you get a code, you put your scanner on, usually you have no communication. You can't just right away say that it's the problem of the PCM. Now, the PCM, like we said before, needs 12 volts. It can have multiple connections of 12 volts. Ignition power is 12 volts. Ignition power is 12 volts. Many grounds, 1, 2, 3, 4, 5. We have to examine and make sure all these connections are getting proper voltages. Why? Why can't we just measure one? Well, because there are multiple circuits in this and modules within them. We don't know which is feeding which. To be on the safe side, right? In order not to say, well, it's the PCM, which is a costly, obviously defective part, we have to make sure they get 12 volts. Like just like you see over here, you have fuses, you have relays. We have to make sure 12 volts is getting through the fuse, getting through the relay. And usually the fuses are identified by ECU fuses, sometimes PCM fuses. So you have to make sure always all the proper voltages are going to those PCM boards. Now, another question was asked about, he saw a video about replacing certain components on PCM boards, printed circuit boards. And he was wondering because they replaced a part, a capacitor, and asking about damaging the board. So let's address that issue before we go back to something I wanted to address later on about PCM. Now, as you know, I made a video one time about printed circuit boards. These are all printed circuit boards, scrap boards. They're not good anymore. But for the demonstration purposes, I think it'll suffice so you understand my point. So if you change the defective part, let's say you saw in a video to go and change a capacitor. Okay, let's say this is the module for air conditioning, and he said, I'm going to change a capacitor. How do I know the capacitor is bad? Well, sometimes there's a bulge on it. These are called electrolytic capacitors. Electrolytic means that they have polarity. This is pointing. If you see the arrow, that means there are two leads, two connections. This lead on this side is the negative. So there is one lead here, one lead here. If I flip it, these are the two leads. So this side is the negative. This side is the positive. That's why it's called electrolytic. These are also called electrolytic. As you can see, these have polarity. But these are surface mount technology. They do not like static at all. These are called through hole. But, so he saw in the video, he said, change the capacitor, right? But I think I did damage to the board. Now, we have to understand printed circuit boards. And that's why this will get me to the main point that I'm trying to get to. Oh, you have chips all over. These are called chips, integrated circuit boards. Integrated circuit chips over here. ICs, integrated circuits. These are ICs, these are ICs. Okay? Now, a couple of things to take into precaution. When you work with these boards, like you just talked about, especially static sensitive boards, as PCM boards or TCM boards, BCM boards, you'll see it says static sensitive material. Okay? There's a reason for that. These chips can take sometimes 5 volts, sometimes even 3 volts, sometimes even less. When you change a part, and the question of the viewer was, I changed a capacitor. He changed this capacitor, let's say, right? As our demonstration. He changed his capacitor. Now, static builds up in your body. It's from the air. Believe it or not, your body is an antenna, a receiver. It receives signals from all over in the air. That's why if you touch an antenna of a TV in the olden days, you would change the picture. That's because you're acting as an antenna and you have capacitance in your body, in the picofarads. So With that said, if I have static electricity in my body, and you could ask how much, maybe 20, 30,000 volts. That high? Yes, that high. These only take 3 volts, 5 volts, whatever it is, right? Now, I'm changing a capacitor. As this question was, I'm changing this, but I'm not touching any of these components. Will I do damage? The answer is yes. You have to be at ground potential. Remember, you have static electricity in your body. How do you discharge it? You're discharging it by a ground strap going to ground. That means my body is a ground potential. Whatever static buildup is in my body, it'll go to ground. Second thing is you have to put these boards on a ground mat. Obviously, I don't have that. These are just scrap boards, obviously. Why? Why do we go to such great lengths for these boards? All I want to do is change a capacitor that I saw in a video, and maybe I could get away with fixing a PCM or a TCM. Why do I have to go to such great lengths? Okay. As we said before, let's say this is surface mount together with through-hole components on it. Okay? This is, as you see over here, these are through-hole. These are surface mount. Now, the capacitor itself is storage. It's like a battery. It stores a charge. But also, the capacitor that he wants to change blocks DC and allows AC to flow in a circuit. In other words, it charges. It takes about 5 time constants for a capacitor to charge, regardless if it's a surface mount, regardless if it's through hole, regardless if it's polarized or not polarized. It's going to charge. Okay? Now, it's going to allow AC to go through because it's always charging and discharging. DC, it's going to be fully charged and that's it. You can't, current will not flow. But that's not the prime issue here. Now, when you change a capacitor, these are, and I went over this one time, this is where a chip was. Now look at all these little pins that made contact with them. In the microns, these are. These are the issues that we have with PCM boards and TCM boards. It's not heat that's the enemy, it's vibration. When you drive your car, as I specified before, let's say you hit a bump at 80 miles an hour. These chips in the microns with these small little pins come off the pads. These are called pads, not making contact. This is the prime issue. Now, where are you going to put the board to avoid that? There is no place to avoid. Where are you going to put it? Under the dashboard? There's still vibration. Are you going to put it by the engine where it is? There's still vibration. There's vibration all over. That's the issue with PCM that I've been fixing for over 20 years, okay, with automotive. Now, being that as it is, okay, getting back to our issue, how do you destroy components if I don't touch the chips? We have static buildup in our body. These are lines of connections. These are connection lines. Like I said before, these landlines, these are connections from here to here. We took out, let's say this is, and let me find it. Okay, this is hard wiring. Back in the days, as we say, back in the days, we had hard wiring, only hard wiring. 30, 40 years ago in TV sets like I used to work, we had hardware. We didn't have no printed circuit boards. And we made wires from one connection to another. Came printed circuit boards and said, wait a second, we don't need no hard wires. These are the connections. These are the landlines. So, that being said, I'm replacing, let's say, here's a resistor, here's a capacitor, here's a capacitor. You see it says C169. I'm replacing this, and all of a sudden I see a spark. Why? Remember, we have static buildup, but the handling of these boards, PCMs and TCMs, you cannot handle a board over here. For an example, let's say I cannot touch this part of the board, even though I'm not touching these ICs. I have nothing to do with these ICs. I'm just changing this part. But once you touch this, you're an antenna, and you're touching the pads, and the pads are connecting to wherever it's connected to, that static discharge is going through the connection to the component. You don't need hard wiring for static to go to the component. These are the components over here, and these are the connections. So if I touch this, if I'm handling the board like this, that's wrong. You cannot handle a board like that. You cannot handle a board over here. You cannot do that. The only proper way is on the sides. This is the only way you are allowed, until you have the proper ground strap or anything, especially with PCMs. Okay? Here's another board, let's say. How do I handle it? I handle it like this. I don't touch these things because these connections, these pads go to other connections. I don't know if you can see them. These are the connections from here to wherever it's going to. And I touch this, I discharge thousands of volts to the chip, I destroy the chip. You're going to say, but Joseph, I'm just trying to change a capacitor. No. Static discharge, you cannot handle these boards. PCM, that's why you'll see it says static discharge and static sensitive material. There's a reason for that. Let's say this board over here, another scrap board over here, right? Only handle it like this. Only like this. You cannot touch these part of the boards because that voltage will go through, again, wherever it will go through. Okay? So, to answer his question, you could damage the components even though you're just changing, let's say, capacitor, and you didn't touch the other components. Static discharge will find its way. Now, to get to the point, what did we start in the video 12 minutes ago? We started talking about PCMs. You have to make sure, if there's no communications, make sure you measure all the proper voltages to the pins of the PCM. Now, in order to do that, you need a back probe, special connectors that you could put. It could fit into these slots of the connectors. How many of us actually have those? Not too many, right? So, like I said, hopefully, and today is my 2 weeks of finishing with the corona, thank God. Now I could hopefully make videos when the weather allows in the Northeast. It's been really cruddy over here, the weather, but hopefully I can show you and you'll understand much better to go to the connectors itself to measure 12 volts. Again, just because you do not have communication, remember the fuses, they feed these points of the PCM. Now, if I just go to the fuse and I measure 12 volts, does that necessarily mean that I have 12 volts at the connector? It's to the pin? No. There could be a broken wire. Now, let's say the fuse blown. The fuse is blown, as we said before. If the fuse is blown, I have a short to ground somehow, or I have a short. Not a dead short, maybe a short. So, this is the wiring we're talking about, okay? From the PCM, if this would be the PCM, the computer module, any of these, you would have 200 wires or a connector. Let's say this is the connector, okay? How many pins there are, whatever there are over here. This is the connector itself. I have pins. I have connectors with wires. Let's say if this is 4, whatever it is, 10, whatever it is, 10 pins, I'll have 10 different wires going into the connector, then I plug it in. Fine. I plug it in. I have to make sure that 12 volts is adhere going through those wires, those hard wiring, and that's why I came to this point. There's a difference between printed circuit boards and the hard wiring. Hard wiring, as it goes to the PCM, the harness is called, is all over the car. Therefore, there is a problem with sometimes, like we said before, the insulation might be exposed. What do I mean by that? That means this is insulation. Let's say it's torn. or the insulation is exposed, meaning the copper of it or whatever will be making contact to ground. Now, alternator frame is ground, engine block is ground, metal is ground all over the chassis. Let's say this is ground. Let's take it a little so people can understand. Let's say this is ground, and let's say this is my hard wire. Let's say I have a hole in it. This hole, how big does this hole have to be to cause a short to the chassis of the auto or the car? Does it have to be 1 inch, 2 inches? No, it could be the size of a pinhole. Once this is exposed and this is ground, let's say this is the ground of the chassis or the alternator or the engine block. Once this is exposed and it touches it, that's it. That's enough to blow the fuse. It could be the size of a pinhole. Why? Because current finds the path of least amount of resistance. A dead short to ground is 0 ohms. The current, the flow of electrons, love that path. They say, thank you very much. I will take that path and it will go right to ground. So obviously you will blow the fuse or melt the wires, or you have fusible links and melt anything, but something will tell you that too much current was being pulled. So if the fuse is blown, obviously you have a short. Now, when I measure, let's say this is a meter, as we've seen in other videos that I did, just to measure a wire, a hard wire, from one end to the other end will give me 0 ohms. Okay, if it's good. Let me ask you the question. Let's say I have exposed wire. Let's say this insulation came off. Will the resistance change when I measure with the ohm meter? No. Just because it's exposed, the ohm meter will tell you there's a connection from one end of the wire to the other end. It will not tell you that there's insulation has been exposed and it touched the ground of the chassis or the engine, whatever it is. It will not tell you that. It just tells you from one point to another point, I have something called continuity. Continuity, like we said before, means I have a connection between one point to the other side of that wire. That's why, come to the computer, you have to make sure that this wire right here is not broken and complete, making a contact from this point to this point to it says ignition power, making contact from here to pin 35 to pin 36. That's why you actually have to go to the connector as close as you can to the PCM. Very important. So with that said, with that analyzation that's been said that we just spoke about, how do we know then? Let's say I blew the fuse, right? I found that, fuse is bad. It's not the PCM, it is the fuse. Oh, how am I going to know? Am I going to follow the whole length of remember, from the PCM to the harness to the battery to the fuse, quite a good length of wiring is involved. Am I going to look with a microscope to look if I see something exposed? Of course not. What you do is you leave a probe. You leave a probe, like we said, like I'll show you, hopefully, like I said, weather permitting. When we go to this part of ohms, put on ohms, like you see the other ones, you wiggle the whole length of the wire. When you wiggle the whole length of the wire, if something is exposed, the reading on your ohm meter will change if that exposed part is making contact to any ground. That's the key. The fact that you blew a fuse when you were driving or when you hit something tells you some vibration is going on. And some vibration going on, hard wire has been ripped. Let's say you're up in the Poconos, in the woods. And obviously in that environment there's rodents and they get into the car and they love chewing on these wires. So therefore, you'll have something exposed. When you have something exposed, again, the ohm meter will just tell you there's a connection from one point of the wire to the other one. There's a connection from here or from here to here. It will not tell you if this wire, which is this wire, is exposed and it's going to touch ground. It will not do that. What do? Leave the ohm meter here, the other one on ground like I explained in the video. Wiggle the whole length of the wire. Wiggle the whole length of the wire. See if the ohm meter goes to 0 ohms. If it goes to 0 ohms, something is touching ground. I hope this was informative, and I hope I answered the question of the comment about the PCM and all that. In other words, when it comes to PCM and you want to do your own work, hey, you have nothing to lose, because you know why? If the PCM is not good and you're going to change a capacitor or whatever it is, then you know what? You're not going to lose anything anyway. You have to get a new PCM board anyway, or program it, whatever. So you're not really losing anything. But remember, if the capacitor is the problem, but I went and I touched other conductors or connections and I blew an IC, then you know what? The capacitor could have done it to repair it, but you blew other ICs. So you have to use precaution with these type of surface mounts. Always on the bottom, on the top, there's components all over. You see over here, there are components on the bottom, there are components on the top, and these are multi-layer boards on these PCMs. People who do not, in mechanics, they never worked on these boards. They don't realize these are multi-layer boards. There are layers inside these. One for ground, one for the B+ line, one for the 5-volt line, one for 3.3-volt line. There are multi-layers. It's like a sandwich. You cannot see it. All you see is the top and the bottom, and it says, oh, that's all. It's 2 layers. No. Could be 6, 7 layers in here. This one could be 8 layers in here, thick as it is. Okay? So use your discretion, okay, with those things. But remember, if you have no communications to BCM, anything like that, you have to first prove to yourself, I have 12 volts going not just to one connection, to all the connections that need the 12 volts, all the connections with the grounds. Very important. That's very important. You don't want to say the board, the PCM is the fault when it's just a bad relay or a bad fuse or a bad wiring, a hard wiring. Remember, hard wiring, you have problems, multi-problems with hard wiring. I hope this was helpful. Please go to my channel, Joe Electronic Schematics for Auto. And like I said, I made a video about a year ago how to replace parts on PC boards, but unfortunately there was no interest, not too many views, so I never continued the subject. Why continue it if there's no interest? So now the channel is a little better, thank God. So hopefully I'll see one day. If there is interest in this, I'll show you how to take off these components the safe way from these type of boards. So I hope this was informative, like I said. Thanks for the well wishes. Feeling a little better. It was a tough disease. It goes right to the lungs, like I said. And if you have lung problems like me, it was tough, but getting along. So anyway, thanks for the well wishes. Joe Electronic Schematics for Auto. My other one, if you do not see any video, Automotive Electronic Schematics by Joseph, that I'm working on. So thank you all for the well wishes.